Hey folks, I wanted to take a minute to show you and demonstrate for you the latest developments we have in 3D animation software. I'm talking about our Beyond 3D, which works along with Beyond, and also our plugins for 3D Studio Max and Cinema 4D. Now, the latest features I'm going to be demonstrating today are Soft Line, Beam Brush, a depth cube, which can be used along with Beam Brush, and Z-axis output. Now, I'll be demonstrating these features on our Beyond 3D software, but everything I'm going to be demonstrating works along with the 3D Studio Max and Cinema 4D. It all works in the same way, and I'll be showing that too. Speaking of that, we have spent time working on these plugins and really refined the user experience. It's a much smoother workflow. Basically, everything is just working a lot better now, and on the plugins, we've increased the rendering performance by a factor of 4. So there's quite a bit of difference between this version of the plugins that we're going to be releasing here as a part of Beyond 5.0 and any previous version of the plugin. So now, speaking of plugins, we are working also on plugins for Blender and Inkscape, and everything I'm going to be showing you today works along with those plugins as well, in almost exactly the same way. So I think we're very excited about that. And as the last note, I would like to give a shout out to the team here at Pangolin who's put together these products and you just really shines through. It's Kathleen, who's going to be working with us since 2002 on the Cinema 4D plugin, and she does all the installers for the plugins. We got Alex Stomple, who does a great job on Beyond 3D. I've kind of come out of retirement and done a lot of programming on this one too. And then we got a new guy named Vladimir. So we put together a real dream team for 3D animation software, and it really shows because these are by far the best 3D animation software and plugins that we've ever put out. I think you're going to like what you see. So without much further ado, let me jump behind the computer and just start demonstrating and show you what we got going on. Okay, so we're going to be demonstrating some new features here in the Beyond 3D software, which also applies to the plugins for 3D Studio Max and Cinema 4D. So whenever you start for Beyond 3D or the Cinema 4D or 3D Studio Max plugin, the very first thing you need to do is really click on the cube where you want the rendered animation to go. And in this particular workspace, this queue is as good as any. It has nothing in it, nothing to get overwritten. So I'm going to start here and right click and then select Create a New Beyond 3D Animation. When you do this, it will automatically launch Beyond 3D, just like you see here. And I'll just build a kind of a generic scene, very simple with a cube. Just click the cube button here, it plops one into the scene. What we'll do now is we will change this to the laser preview window. It's just something I always do. So I'll say shading, change this laser over black, and then we will make this one view the camera, since I'm going to be working with the camera over here. And then the last thing you could do is click on the button up here that says Enable Laser Output. If you click on this button in any of these views, it will send that particular view to the laser, and it allows real-time rendering. So you can see what it looks like on the laser. So okay, so we've got our nice little cube here. And what I want to do for this particular demonstration is turn this into the old school wireframe laser show type cube. So to do this, we click over here onto the laser settings of the cube. Tell them I want custom line types and that we want this thing called show back faces. When we do this, it will show everything through the cube. It's make it basically kind of transparent wireframe. So there we go. There's our wireframe cube. So the very first new feature that I'm going to be showing you today is what we call soft line. So this is found here in the laser section. One of the things that you'll notice here is that we've always had the sections on line types, line color, filter settings, point placement, but we have some new sections now. One of them is soft line and one of them is beam brush. So I will demonstrate the soft line now. We'll just expand this. And all of these things work in the same way, is that when you first expand them, you have to turn on the area you want to actually customize. So in this case, I'll go ahead and turn on the area indicating that I want to customize the soft line settings for the scene and enable the soft line feature, which you will see it take place immediately. So now what you have here is a number of adjustments in how the soft line is applied to the particular object. And all this stuff works on an object by object basis. So to demonstrate this, what I'll do is actually put another object into the scene too. So I'll click on my Move It tool, and we'll move this to the left a little bit, and we'll add, let's say, a sphere. We will make the cube maybe red, and the sphere green. Maybe back the camera away a little bit, or click on the Resize Them tool and make the cube a little bit smaller. All right, so now we've got our scene, and the point I'm demonstrating is that each one of these has its own settings. So we have this one where the cube, I said that I want soft line, and I want the soft line working in this way. In the sphere, let's make the sphere a little bit more interesting. Like I want to show what we call, let's see, object edges, and we'll make the sphere a lot simpler so that it's not flickering on the laser so much. But once again, this really helps to demonstrate that we have separate settings for each of these objects. On the sphere, we don't have any soft line, and on the cube, we do have soft line. So I'll go ahead and enable the soft line on the sphere just to show kind of how that looks. And since the sphere is a lot more complex, you could see that the soft line really doesn't work all that well on this particular thing. So, but it just is very handy to have the separate settings on an object by object basis. So I'll go ahead and click the cube and demonstrate the soft line settings and exactly what they do. And maybe we'll make the cube white for that, since white really shows up and shows this feature pretty strongly. So you have the soft line, like I say, we've got the enable disable button, and then you have different adjustments for it. First, we have the adjustment of what happens at the beginning of lines, right here. We have a separate adjustment of what happens at the ending of lines. And then we have yet another adjustment of what happens in corners, like this. Now, since the cube has a number of lines, some of them are connected and some of them are just separate lines, you can see the effect of each one of these controls. And then finally, we have this thing called minimum brightness, which shows you that right now, if we set the minimum brightness % to 0, what it means is in the corners at the starting and the ending of lines, the brightness will go all the way to 0. Now that looks pretty strong. For some things, it might be a neat special effect, but for me, I found that 20 works out pretty well, 20%. And then finally, we have this thing called brightness linearity. And this affects how, and what this is points, by the way. So this means over the period of 8 points, it's going to go from, in this case, 20% to full brightness. But how does it go from 20% to full brightness? So that's really where this control comes in. And what I'm going to do to demonstrate this control is make it even more dramatic, to go to 10% brightness. And the point of this control is that as this goes higher, like you see more towards, basically increasing in number, greater than 1, you can see that the effect takes place over kind of ramps up really slowly, not becoming full brightness until the very end. Maybe I'll click down here and show this even more dramatically with fewer points here. So that's what 2 looks like. It almost gives it a speckle effect, like a specularity, like a mirror finish. As this goes, 1 means linear, which means it will just make even steps, even brightness steps across the 6 points now to get to the full brightness. But as we go lower than this, the steps are what's called logarithmic. It means they kind of step up more quickly. And for soft line, I found logarithmic works really well. A value of 6 works well, and we can go up to a 20% minimum brightness there. A value of 0.6, sorry. It's, yeah, so 0.6, you can see how soft that is. It really gives it a good look, but But this being an artistic tool, you have complete control over all of this. And it just gives a lot of control and creativity. So now on the sphere, I'll try one last thing, which is we'll turn off all of those lines. So we're just seeing the outline of the sphere, and I'll demonstrate one last part of the soft line, which is and to help demonstrate that, what I'll do is increase the segments to demonstrate this last control called at round overlaps. Now, normally in soft line, you don't want to interfere with what we call the round overlaps. But if you do, what you could do is you can increase this here. So this says that now over the period of 13 points, it's going to increase and decrease the brightness to basically create a soft line effect on that circle. And let's see, I can further customize this by changing the point placement settings on the sphere. And let's say, change the curve detect down, and fewer points. Change the point density here. So you can see that we have fewer points in here that this soft line operation is working over at this round overlap. So like I say, typically on round objects, you don't want any soft lines. So that's why the default value is 0. But if you do, you could just increase it here. And so that's what this control does. Soft line at round overlaps. Basically works on circles. So that's the soft line feature. Hope you like it. So next what I'll do is I'll change the scene up a bit and create a brand new scene. That's what I did. Say file new, creates a brand new scene. And I'll plop in a hedra. We'll go ahead and turn on laser output there, and we'll make this hedra a dodecahedron, which is 12 pentagons. Make that nice and big. Push the camera in there. And once again, turn this into the laser preview. Let's see, camera. So now I'm looking at the camera, the same view as I'm looking at up there, and show you the next feature, which is beam brush. So beam brush is a new technology from Quant and Pangolin that allows variable beam divergence, basically variable beam diameter in real time in an object. It can be done many times. The frequency is very high. You can just do so much with beam brush, and I'm going to demonstrate just a little bit of it here. But once again, just turn on the beam brush feature here. And in order to properly use the beam brush feature, what we need is some additional information, because what the beam brush feature really does is map the Z coordinate onto the beam brush, basically. So it makes the things that are farther away one beam brush, and things that are closer to you another beam brush value. So to help to see that, one of the things that we've added is the show menu at the very bottom, rear Z and front Z. So this tells us the front Z and the rear Z of this particular scene that we're looking at right now. And what I'm going to do is I will make this dodecahedron a wireframe as well, just like we did with the cube, just like that, so that we can really see the beam brush. When I turn on the beam brush, and you can see everything is big now because we didn't really enter in these values. So what this says is that the front Z is 4.2. So if I put a front Z coordinate as 4.2, and this tells us that the rear Z is 6.0. So if I type 6 for the rear. Now what we have said is that in the rear of this, which is a Z coordinate value of 6, we want the corresponding beam brush to be 0, which is the smallest, and the corresponding brightness to be 60%, and I'll talk about that here in a second. And what we said is in the front, which is the Z coordinate of 4.2, we want the beam brush of the front to be 50% and the corresponding brightness to be 100%. So if you want the this whole thing to be just a single beam brush value, what you do is you put this, just the same number in both. So for example, if I put 35 here is the rear and 35 here is the front, now everything is 35. So that's an easy way to make everything. If you want to make a single object, just a single beam diameter, you don't even really have to worry about the Z coordinate for rear and front. You could just put the same number in for the front and the rear, and that will make a single beam diameter. So I'm going to demonstrate one more feature here, which is depth queuing, and then I'm going to tie it all together, which is this. So this feature is actually a dual feature. Not only does it control beam brush, but also brightness as well. So what we said here is that the Z coordinate for the rear is 6, and when you have a Z coordinate for the rear, which means farther away, make the corresponding brightness. I'm going to make it 20% just to really drive this home. So you can see that things that are far away are dimmer, and things that are very close are brighter. And as I move around here in the scene, you can kind of see how that works. As it gets farther away from me, it gets dimmer. As it gets closer to me, it gets brighter. And so that's why this feature is a dual feature. And you could use it either just as a depth queue effect, or just as a beam brush effect, or both. And the reason why it's really handy for beam brush is now I will go ahead and enable beam brush and show you what this looks like. Now I'm going to make the beam brush and the brightness in the rear be 100% just to really demonstrate this. And so what we've got is a situation where the laser in the rear is a very small beam and the laser in the front is bigger, and I'll make it even more dramatic like this and push that camera in even more like this, and maybe we'll make the Z coordinate for the rear a little bit further away like that. The front 3.6. So what we see is that the brightness of the laser in the rear is just, it's brighter to your eye. I'm not sure if it's really coming across in the camera, but it does look brighter to your eye. And because of this, what your eye wants is a natural depth queue, which means that things that are farther away are kind of dimmer than things that are in front. And so, and especially on beam brush, when as you make the beam diameter bigger, it naturally gets a little bit dimmer. It's not too much, but it is a little bit dimmer. And so to help to really enforce a good depth queue, we've added this this feature in here where you can control this. I'll make the brightness of the beam in the rear 30% just to really show. And now you can really see that the beam is not only bigger in the front, but brighter in the front, and that the beam is not only smaller in the rear, but also dimmer in the rear. So that's how this works. And like I say, it's a dual feature. You could use either one of them separately, or you can use them both together. So if you don't have a beam brush projector, you could still take advantage of this feature. So the last thing I'm going to be demonstrating is Z-axis output. And to do that, I will continue to use this dodecahedron. And let's see, what we'll do is we'll tell Beyond 3D that I just want to output a single frame, just this one frame. I'm not creating an animation. And show you what it normally looks like. So I'll just go ahead and render that, hit save, and we can see that it's 3D. We can move it around here in the window, and we can see it definitely has transparency. But when we go over here into Beyond, what we'll find is that what was actually sent to Beyond is a flat view. It's a 2D view of this 3D object. And so if we really want to take advantage, like for example, let's say we've got this and that I wanted to create a rotation with it. What I'll do is I'll create a key effect, geometric rotation. And what we'll do, put a key here, and I'll move the timeline over here, put a key here, and on this one I will say I want this to rotate 1 time, and then rotate this 2 times, and rotate this 3 times, and I call this a 1, 2, 3 rotation. And if you click play here, you're gonna see it's going really fast, so we'll slow that down. Maybe something like this. Yeah. So you see it's like a piece of cardboard. It's just like, it looks 3D from the front, but it's really just a piece of cardboard. So if we really want to rotate this in Beyond, not just in Beyond 3D, what we have to do is include Z-axis information. I'll come back over here at Beyond 3D, and this time I will say that I want to create and include the Z-axis information. When we have this checkbox, I'll go ahead and render it, send it to Beyond. We'll take a look at that in Beyond now. And now what you can see is that little rotation effect that I created, it indeed is rotating in 3D. Now it does look a little bit funny. It looks kind of squished. If I stop this and then edit it, what we can see is that from this view, it looks squished and it looks a bit distorted in shape. And the reason why is because right now we're using a camera view in Beyond. And if you really want to do this kind of thing, if this is a special effect that you want to make of basically taking these objects, creating them, and then exporting them to Beyond for 3D manipulation, the best thing to do is not to use a camera view, but actually one of the like front, top, or side views. And there's another tool. So for example, if I say front view, that would be one of the views that you can use. There's an even better view that you can take advantage of here called orthoball. And when we go into the orthoball view, it allows us to not only have this non-perspective view, but also to orbit around on the object. So I'm here, I've got this, and so what I'll do is I will come over here and say in the render settings that I want the view, the output that I'm going to be using, to take that top view, that what we call view number 1, which is the top left, and it tells us orthoball because that's the selection that we have right now. So now that I've set this up in the render view, I will go ahead and export that to Beyond and click Save. And now in Beyond, what we see is that it is no longer distorted or squished, and it just looks perfectly. And to prove that, what I'll do is edit it. And you could see that it is just perfectly round, not distorted, looks beautiful. And so now what we can do here in Beyond is further post-processing. This key effect, this rotating key effect, is one example of that. Another example might be a color effect. We'll just go ahead and splash some color on here, but this is the normal. But what we can do is we could say we want to map the color to Z-axis instead. And what it says is that things that are in the rear are red and things that are frontmost are blue. As you can see there, I'll turn this off for a second. Another thing that we can do is similar. We can add a brightness effect, and I'm going to turn this, I'm going to delete this key effect and make this one 100%, and you'll see why here in a second. But once again, what I'm going to say is do it by the Z-axis, and so this is another way of doing a depth Q effect. And now that we actually have the Z-axis, we can do this. And then another thing that we can do, of course, is add a beam brush effect. Here, this kind of beam brush effect. And to demonstrate this, what I'm going to do is I'm going to delete this midpoint. I'm going to set this one to maximum. And once again, say that I want to map this to Z. And we've created a similar thing where things that are far away are small and things that are close are big. So all of this post-processing is possible. And it may not, because of the way this is rotating, Beyond doesn't have any perspective effects built into the pipeline. You have to add them if you want them. So what I'll do is add key effect, my favorite perspective effect, because I'm the one who wrote it, the Showtime 2000 perspective. And when you add that now, you start to see that it is, you kind of get a lot more of a real perspective in there. Yep. And so all of these things could be combined, right? We can add, do the I would recommend putting the beam brush last, but we have now perspective and beam brush being based on Z. We could throw in a depth Q effect, or even take it the way we really used to do it in the old laser show days, is add a Z clipping window. We'll say window clipping, and then we'll bring up the Z axis. Here. So this is how we used to fake hidden line removal before we had real 3D software. So something like that, you know. So anyway, that's the situation. And all of these things are possible because we have the Z output. And it would be not possible if we didn't have Z output. You just can't do these post-processing things without that. So to help drive this home, I'm going to do one more scene here in Beyond 3D. Close this and close this. And I'll open a scene that we include this with Beyond 3D. Many of you may have already seen this. It's just like a kind of a city flyby type deal. So we'll go ahead and tell Beyond 3D that we want to include the Z output right here on the bottom and render that. Send it to Beyond. And it is here. And since I put it in the same queue that I was already creating all these things, I can turn on my color effect and you can see how things that are in the front are blue and things that are in the rear are red. So once again, the Z-axis output is really made for special effects post-processing that would be done in Beyond that would require the Z output. So just in summary, what we have here are new features in Beyond 3D and also the same features in Cinema 4D and our plugin for 3D Studio Max called LCMax. We have the new soft line feature. We have a new beam brush feature, which can also have this depth queuing effect. We have the new Z-axis output found at the bottom of the render settings dialog box. And all of this stuff that I've demonstrated for you is also found in our plugins for Cinema 4D, which I'll show you here. This is a screenshot that I happened to capture. What you can see here is in the render settings, we have this thing that says show laser frame info in picture viewer. This will show the front Z and rear Z information. You can see here in this preview window, we have beam brush, we have soft line endings, we have the rear Z and the front Z, and right here in the tag plugin for Cinema 4D, we have the soft line and beam brush features added, and they work in exactly the same way and use exactly the same numbers, and it's very consistent from product to product. And in our 3D Studio Max plugin for 3D Studio Max, our Laser Show Converter Max plugin, down here you have this thing that says show laser frame info. That shows the number of points, the front Z and the rear Z, and it can also be seen down here in the viewport. And in our preview window over here, you also have down here enable Z-axis output, just like we just demonstrated. And right here in the utility plugin, you can see here how we've added the soft line and beam brush in exactly the same way as we have in Beyond 3D. And not shown in this particular picture is that these soft line and beam brush features are also found in the modifier plugin, so you can animate these features in real time. So I hope you've enjoyed this presentation, and I hope you really like playing around with the new features of Beyond 3D, Cinema 4D, and 3D Studio Max. Be sure to leave any comments below and questions you may have, and we really look forward to hearing what you have to say. Thank you.